I'm trying this. It says we are live, so I'm gonna
boy.
go ahead and pull up the broadcast on my other monitor.
Excited to be live. Whoop.
Let's check this out. It says last live 8 seconds ago. Okay, now it says streaming live.
Sometimes the Twitch experience confuses me. With things like that.
I would, for me, I agree. I just change sometimes to often.
Yeah.
Yeah. Okay. I will use my phone instead as the second screen because it gets the actual app, which sometimes performs nicely.
Cool. I just got a notification that you're live.
Oh, amazing.
Hello, world.
Hello. Let's see if anyone jumps in. We've actually been, having a great little core of viewers who join me for even my more impromptu streams. Like yesterday, Sarah, the docs lead at Astro, and myself streamed about just doing docs, and we had 15 people watching us do docs. It was amazing.
That's awesome.
So yeah, I like to banter for a minute before jumping into the content just so everyone can show up. And I should actually do a tweet.
I always forget to tweet the streams. I have a calendar reminder, and that's only 75% effective or so.
I know. Okay. Quote tweet. We're live. And I guess you can. I'll stick the tweet link for you. So if you want to.
I have recently started showing people on my streams that when and how I tweet things.
Yeah.
I like the idea of showing all the different various sides of shenanigans, like tweeting and docs.
I think you do these. Do you do tweets that are TypeScript tips, that kind of thing?
I don't. I've been meaning to. I just haven't had the energy.
How about this tweet?
That's a good tweet. I'm happy about that tweet. That's my book, cradling it. But no, what I'll do is I'll about half of my streams are just going through TypeScript ESLint maintenance. So I'll tweet that I'm doing that and then tweet each issue and or pull request as we get to them.
Sweet. Okay. I guess let's see if anyone has showed up yet.
I see if you. I, by the way, really like the what you're doing with your advertising, the
little banner
image. Yeah, the banner.
I'm really glad that you said that because I've gotten feedback that it's too cheesy, but I think I'm gonna roll with it. I'm glad you like it.
Yeah.
Okay.
Cheesy is never bad. We're adults here. We're not teenagers. We don't need to rebel against society. It's fun. Do it.
Yeah, exactly. Actually, now that you're on the screen with your book, can I pull up the book I used to learn TypeScript and you can rate it?
Oh boy, it's gonna probably be a high rating. I gotta let you know.
This one.
Yes. So this one, you mean?
Yeah.
This is a fantastic book. Highly recommend. Dan Vanderkam is great. Gave me a lot of good advice on learning TypeScript. I reference effective TypeScript at least once or twice in learning TypeScript. It's a fantastic book. I'd say we're not quite competitors, although you can learn TypeScript through effective TypeScript. It's really more targeted to people who are a bit more advanced and or already know TypeScript. While it also supports beginners, while mine is more targeted to beginner, intermediate, and also supports advanced.
Yeah,
there's overlap, but
that makes a lot of sense. It's this is structured as here's a bunch of tips, which I did not read all of them, so I don't know. I'm not a TypeScript expert by any means. All right, so people have joined us, so thanks so much for joining, and I guess we can get started. So for those. I always try to introduce both of us. So for those who don't know me, my name's Dan. I do Astro, which is a static site builder, and Solid, which is a front-end framework. And this is my special guest, Josh. Josh, what do you do?
Oh boy. I don't have a job. I work on open source and consulting full time. Trying to emphasize open source a bit more. My main thing is I work on the TypeScript ESLint core maintenance team. So we help complain about your TypeScript code and JavaScript code automatically. And I also recently published a book, Learning TypeScript through O'Reilly, which you should all buy and give 5-star reviews on every platform available to you, please.
With every book, you get a picture of Josh holding your book. That's not true.
I'm happy to take a selfie with a book and send it to people on demand if that would make them happy. I don't think it will.
Awesome. So thanks for coming on, and thanks everyone for joining us. We're doing a shared Excel job where we can sort of like break down. I'm going to delete this picture for now. Where we can break down the concepts that underlie TypeScript. We're going to learn TypeScript and we're going to try TypeScript out. But what's super interesting about the ideas we have here on the screen is they're not just about TypeScript. So we have documentation, catching issues, and developer tooling. And Josh, I'll hand it off to you to sort of explain why are we starting here?
Sure. I'm so excited. Thank you for having me. Also, thank you for introducing me to Excalibur. I've been wanting to use this thing for so long. I like starting off with a piece of code. Am I using Excalibur right? Is there how do you left align this? There we go. So like, let's say that you're writing a piece of code. I'll indent a little bit. And or maybe you're looking at an existing, I don't know, code base that involves painting or painters or something. And just looking at this code in isolation, or even with some fictional other code around it, this is JavaScript, and it's really hard to tell what's going on here. You don't know what painter is supposed to be or painting. You don't know, is this the right way to call get materials? Does it take, parameters? Is that what it's called? What does paint take in return? So although there are ways that people have started to document JavaScript in line with like little JS doc comments, there's nothing really formal in the language that like documents what things are supposed to be well, or even effectively, and forces you to do things right. Like, it's very easy to accidentally only JS doc one of the parameters, or let's say this gets changed to string, or what if painter changes? What is painter? What is this object type? So TypeScript provides a set of syntax on top of JavaScript that lets you document things really formally. And because it's a formal definition for how to describe what your code's supposed to do, TypeScript can then catch issues for you when you mess up, which will happen because we're all developers. And it'll give you a lot of nice developer tooling to work with your code and types.
So, all right, let's sort of break down this example. First of all, it's a tongue twister, which is wonderful. Painting, painter, painting. But the idea that you're getting across is like, wait a minute, what is painter? How do we know it has get materials, right? And then how do we know get materials is called like this? And how do we know paint is called like that? And so this example at the top is sort of like a previous way of trying to explain those things.
Yeah. I like to joke that JS comes from Java. And if there's one thing that should convince you not to use it, it's that it comes from Java.
So it's interesting. Java has types in it. So in Java, the goal of the doc, this little feature, is just to, I guess, explain what the parameter is in plain English. So the idea behind like documenting your code isn't just writing documentation separately, because sometimes when we say documentation, we mean like what I do, which is like creating guides and creating API references and creating all these things. But even inside your code itself, you want to be documenting the objects that you use. And whenever you create a new thing in your code, like a function, you want to use whatever's at your disposal in the programming language to make sure that it's easy to understand. Sweet. So TypeScript can help us do that. Before we actually show TypeScript, let's talk about how TypeScript can help us like catch issues.
Yeah. When people say documentation, the first thing that generally comes to mind is strings, English, which is a very valid and important part of it. But it also can mean, at least in this context, documenting the structure, the shapes of your values. Maybe you know what painter is supposed to be, so maybe explaining that the painter is a painter or some similar string is not important, but knowing what methods, what properties it has, that's really, for many times, the important documentation. So TypeScript lets you describe this really formal way of what's on an object, whether it's a string or a particular shape or whatever. And then on top of the new syntax that you can now write it, TypeScript comes with a type checker, which is able to catch issues if you say declare that painter has get materials and then you accidentally do like get my materials or some incorrect name like that. So TypeScript will look at your code and yell at you very kindly if you mismatch between expectations and reality.
So the way we catch issues, you mentioned the type checker, right? So let's add that here. And I can draw like a quick little line. And on the documentation side, you mentioned like the shape, right? Typing your code, describing the shape of an object is like one example of that. And that's a way you can document your object. Cool. We got to use.
I love these little
arrows.
Yeah.
Yeah. And the last little box is developer tooling. And I guess from my perspective, it makes sense to call this a developer tool because, well, it's a tool that you use when writing code.
Yeah. And because TypeScript is able to enforce that your code looks and feels the way it's supposed to, it can then give you a lot of tooling on top of it. So TypeScript is really, I like to say, four things. It's the language itself, it's the type checker on top of it, it's the compiler tool, which is a command line app that does the type checking, but it's also a set of services called language services that your IDE, your editor like VS Code or RIP Atom can use, where you can say right-click on a name and ask to go to definition or find all places that name is used or rename the name to something else, which is kind of possible in JavaScript, but not super easy. Like if you have a bunch of places in code that say get materials is called and you want to rename it to get my materials, it's pretty much impossible in JavaScript to know whether you're renaming just the painter's get my materials and not some other instances. So TypeScript lets you do much more powerful dev tooling, which can really save you a lot of time in code, both in investigating things and in rewriting things.
Yeah, I love that it's a tool that your tool can use. Mm-hmm. It's not just right. The CLI is something you would use, right? You would run the TypeScript checker in your terminal and then get a bunch of results. But your other tools, your IDE, can also use what TypeScript provides. Okay, sweet. So what to do next? Do you think that this function, we could plop it into a playground and type it, or is it like referring to too many other things?
I think we could do it. I'd say maybe remove the TS equals from the URL in there. So fun fact, the TypeScript playground, typescriptline.org/play, is a fantastic place where you can play around with TypeScript. You can specify different TS versions and stuff. On the left-hand side, 2/3 of the screen, you see TypeScript source code, which you can write. And on the right, you have tabs for the equivalent JavaScript, because all TypeScript code compiles down to JavaScript code you can then run. You get errors. DTS is a declaration that can be output of all the types in your file so that other tools can look at your code, which if we have time, we can get into later. That's a whole other area.
Cool.
But yeah, if you want to just wipe the, yeah.
All right.
Cool. So this is an example of TypeScript giving us a complaint by default. It can be configured to not, but when you don't specify what the type of a parameter of a function is, TypeScript will yell at you saying, hey, you didn't tell me what this is. I don't know what it is. So it's the implicit any type, meaning it can be anything. YOLO, I'm not going to type check it very much. So that's not good.
So the error we're getting comes directly from TypeScript, and it goes through this editor, which I think is called Monaco. So that's an example of the language service, right?
Yeah, exactly. Yeah. Monaco, by the way, is a fascinating project, which I would love to eventually do a stream on. It's copy and pasted from VS Code automatically into a package that you can then run in your browsers.
Sweet. So yeah, this should look familiar to you if you've been using VS Code. And okay, so I see there's a quick fix. I imagine you don't want to do a quick fix.
Let's try it out, actually. I love to see. They changed this version to version. It might work.
Infer parameter types from usage.
No, never mind. So I'll say TypeScript, although it's already on version 4.8, just came into beta, it's still a relatively new tool in the grand scheme of things. And it's always accepting pull requests and issues to make the dev tooling better. So in this case, I'd say you'll probably want to type out something like interface painting with a capital P, and then object brackets. So now we've declared that somewhere in our code, there's at least one instance of this painting type, where right now we haven't declared anything on this shape, but that is an object shape. So you could give the interface painting a method on line 2, like get my materials, parentheses, parentheses.
Oh wait, the painter has the get my materials. The painting is the
shoot. Wow, thank God for TypeScript and you to catch that.
It's cool. We still want to declare an interface for painting, right?
Yeah. Let's say yes.
So we're going to declare an interface for painter. So the idea of an interface is it's an object. It's a kind of object in my code.
Yeah. It is a list of things that exist on anything that is declared to be that object or that shape. So when you say interface painter, and let's say painter has a get my materials method, which you can type, yep. And then you would put 2 parentheses here, and we can stop for now. Sorry, one of my cats is doing unsavory things. So yeah, and then
is there supposed to be a colon?
There is not before the parentheses, but there is after the parentheses. So get my materials, parentheses, list of any parameters, colon, and then the return type. So for now, let's say that it returns a type called in progress painting or something like that. And we'll have to declare that as an interface too.
I'm going to call this rough draft.
I like that more.
I don't want to type that much.
Cool.
Okay. So what this does is it says, there's something in my code called painter. I'm going to give you a list of things that painter has. And one of the things is get my materials, which is a function. I guess that's what this part is.
Yes.
And returns a rough draft object. So now we can, I guess, declare a rough draft as well.
Yep.
So now that we have painter and painting, can I say that this is a painting and this is a painter?
Yes, which you can do with name, colon, space, and then the type it is. Yep.
All right.
Nicely done. So there is a little bit of pain when you start using TypeScript, which you and I just experienced together gloriously. It's that you start having to type out things, which is a little bit more work. You're now restricted. You have extra things to do. You have to say, well, I mean, you don't have to. You can configure TypeScript to allow you to not, but it's better generally to describe in detail what everything is supposed to be. And because, sorry, go ahead.
I can imagine that, hey, like we have one function here. If we had like 15 functions that all refer to different objects, it would take hours to write out every single one as an interface.
Yeah. In my experience, normally the biggest pain is right up front when you start adding them, and functions generally reuse interfaces types between each other. So if we had 15, you'd probably only end up writing like a few more and then reusing them. Mm-hmm. And then also in my experience, once you convert a non-trivial amount of code from JavaScript to TypeScript, you tend to find bugs, which feels very good and validating for why you're doing all this work in the first place. I will say I've never seen or participated in a TypeScript conversion more than a dozen files that didn't find at least one real production bug.
I love that. It's almost like it forces you to, like, aside from TypeScript itself, reviewing your code, it also forces you to review your code because you have to go through all of it.
Yeah. I mean, that's not even TypeScript being great. That's just, a forcing function. It's fantastic. We should do that more often. And
Cool.
here, TypeScript is forcing us to do better at documenting our code because it's telling us, hey, I see get my materials has returned some rough draft thing, but rough draft doesn't describe what paint is supposed to be.
Yeah,
so I don't know what paint is. I'm going to yell at you.
It sort of guides us to doing the next step, which is, I can go in here, declare paint. And I can say, okay, well, I know that this time I want a kind of parameter. I want painting. Can I go do the same idea as I did over here and say paint? Oh, what's going on? Painting. Okay, so what's going on, by the way, is I'm used to my Vim extension.
Oh.
So, hey, Fuzzy, thanks for joining. StreamYard actually lets me show your comment on the screen. So Fuzzy is a huge friend of mine and a teammate at Astra. So.
Hi, Fuzzy.
Okay, so I can say painting, and now it's gonna. Can I say void if it returns nothing? Actually,
yes.
I wouldn't know that as a beginner, though, right? That's not something you know from JavaScript.
Yeah, and void actually is a really interesting type. We can go to later. So let's take some artistic license with the code here. Like, what do you think this code should return, given that we're just writing it for fun?
Yeah, so if the painter gets the materials and paints the painting, I wonder if the painting the painter could fail, and maybe we could return an error or a boolean or something. Maybe it returns the name of the painting, or rather, I think it just returns the painting back to us. Like, we can do if we call the painting method and it returns the painting that was painted, we can then call more methods on the painting.
Let's do it.
So now it returns painting.
Awesome. Cool. I will note one small nitpicky thing. We normally don't put a space between the name of a method and the parentheses. Although I find spacing fascinating, and I'm wondering if actually it would be pedagogically better for the language to do that, to separate out name, parameters, return type. But I don't make decisions.
The drawback is it wouldn't match with how we call things in JavaScript. The pedagogical benefit is you can scan through each chunk and each thing is different. So I love this. I love talking about this kind of thing. Like, what can the design of the language do to be more learnable? And it's cool to have you on, because from my understanding, you actually are participating in those discussions, like on the TypeScript team.
No, I still can't tell whether they barely tolerate me or enjoy any of my shenanigans. I'm one of the more common, not the most common, external contributors. And I've been wanting to contribute more, actually. I just haven't had time. But I've contributed a few features that get blogged about in the release notes, and a bunch of small bug fixes and smaller features. But
you're not
the team.
You're not on the team, but you're loud enough that that they know who you are.
Yeah. Sometimes I get subtweeted when I'm wrong, or just directly tweeted that I'm wrong, which is a very good feeling. I like it.
Fuzzy just bought your book.
Thank you so much, Fuzzy. I appreciate it. I also don't have a Kindle. I can't stand electronic book reading for this type of thing. I need the paper,
On a separate stream, I'll do a rant as to why I love single-purpose devices like Kindles from a design perspective. But that's not this stream. We typed our paint method. Man, I love that this verb is very confusing, because we typed it, but we also typed it.
Yep. We painted. Yeah.
But we already got to a point where we're not being yelled at.
Yeah, TypeScript's happy with us, and we haven't even finished describing it. Surely there is something in the painting interface. Surely there's a name or rating or materials or something. So whatever you wanted to put in there.
Yeah. Sure. Let's give it a name.
Sure. So if it's just a property, you don't need the parentheses. Yeah, it's just name : whatever the type is. Let's say string.
How do you learn if you're getting started in TypeScript? How do you learn what all the different possible types are? Because string is kind of obvious, but void was not.
Well, you can read my book. There's actually a very small list of them. It's maybe 10 or so important types. Yeah, the TypeScript docs are fantastic.
Everyday types. I love this. Here we go.
Yeah, there we go.
So if you read this, you'll learn like, oh, string, number, Boolean, and then it goes through arrays, and then of course the any keyword, which I am going to talk to you a whole lot about that.
Oh boy.
So you can check out this guide as well to learn about all the types. But in this case, we kind of know that strings are a thing in JavaScript in the sense of, they're supported directly in the language. So this was kind of obvious. So it can have a name, and then maybe it can have a reference to the person who painted it. So I could say like painter.
Sure. Fun fact, we typically use semicolons at the end of each property, but I don't have a hard opinion versus using commas. I'm curious if you have a pedagogical reason for that.
Why are both supported?
I don't know.
Okay, I'll give you the I'll give you the pedagogical reason. If I do like const painting, it matches up like this: name something,
True.
comma, not semicolon. That won't work. So that was like that reason.
It makes a lot of sense.
Anyway, Fuzzy says, don't read the TypeScript docs. It's absolute torture. We should be a little more supportive of documentation efforts, but maybe there's a way to contribute that we can do a stream where we contribute to the TypeScript docs.
Yeah.
But I guess that's why people like you write books, because sometimes the documentation doesn't work for everyone.
Sure. I would say all the time, all of the documentation does not work for everyone. Like everyone has different brain patterns, different ways they learn. And even if the docs are perfect, which never happens, sometimes it just doesn't work for you. I'll also say, I suspect you'll agree with me on this one. Good documentation requires constant iteration over time, user feedback, taking a fresh look. And the TypeScript docs now are on like the second major iteration, which is 2 of presumably you'll need at least like 4 or 5 to get any docs site to be really good. Yeah,
that we are currently rehauling from scratch the solid docs. So I certainly, I'm not going to put Fuzzy's recent comment on the screen, but you guys can check out the chat for first. Okay, so. We've gotten TypeScript to like us. Can we see what TypeScript does with this in these little...
Yeah.
What happened to all the stuff we wrote?
Nothing. Well, it died. So TypeScript is a superset of JavaScript. That's like one of the early marketing slogans it came with. That means that all the extra TypeScript syntax is just in TypeScript land, but it still compiles down to the remaining JavaScript. So until this fancy types as comments proposal that's running through the JavaScript community gets approved, which will take years, you can't run TypeScript syntax directly in browser, Node, etc. Even runtimes like Deno and TS Node that claim to run TypeScript directly actually remove this syntax internally. So in order to run TypeScript code anywhere, you got to strip out all the new TypeScript stuff that got added.
All right, we're going to add that. It's a superset.
Yeah.
So in that sense, if you call it a superset of JavaScript, it's not just a developer tool, it's also a language.
Yeah.
So TypeScript is both a language and the tools that understand the language.
Exactly. It is unfortunate that we use the same name to refer to all 4 things, but there really are 4 things: language, type checker, compiler, which type checks and transpiles to JavaScript, and then also the language services.
Right. So we're missing. Oh, so here it is. So these are the 4 things. We have a type checker, a command line interface, which itself uses the TypeScript checker, the type checker. So it's kind of like that.
Yeah, I'm going to try to give these nice little blue squigglies. Forgive me for this.
No, let's do it. Let's do it. These are the 4 things.
2.
I love it.
3. Shoot, where's compiler or transpiler? I guess we can say command line interface. Yeah.
So this actually, I mean, yeah, let's describe it a little bit more. It compiler. Like the way to I guess another way of saying this is the language services are not compiling anything. They're not spitting out new stuff for you.
They can direct the compiler to do that, yeah. But typically, when we say language services, we mean the thing that like tells you everywhere that a variable is used or whether it's unused or something. Yeah.
So this is the so the CLI uses the types checker to help with the compiling. There's actually really interesting discussion in chat, like what's the difference between a superset and a subset? And Dave says, since it's additive to the language, it's a superset. And you say, I remember it as a superset because it's super.
I'm so sorry.
Yeah, a subset, I guess, would be taking features away. Cool.
Yeah.
So now that we know like all the different pieces of TypeScript, I wonder if we can. Oh, wait a minute. One of our outputs is has just the types. So it's the opposite of this. This has no types, and this one has only types.
Only types. That is a secret TypeScript team meet. Just kidding. So if you, let's say, publish a package on npm that you wrote in TypeScript, and you want someone who's writing TypeScript to be able to understand the types from your package, you wouldn't distribute your TypeScript code directly because people need the JavaScript to run, but they still need to know what are your interfaces, your shapes, what does each function take in. So there's a file format, DTS, which I really like the explanation you just gave, that it is the exact opposite. It's TypeScript types only. It's not the JavaScript, which TypeScript can then read to understand, okay, your code has these interfaces, these constants and variables and functions and stuff.
The way I understand this last line is what we wrote was like a JavaScript function that defined types along the way. And what this last line is kind of the equivalent for what interfaces do for objects. So like what an interface did for is to say, hey, we have this kind of object in our code. Here's a list of all the things it has. And what this last line seems to be doing is saying, hey, we have this function in our code. Here's its arguments. Here's its return type. It's like, that's why it's called declare function, because if it just said function, it would be like an invalid JavaScript function.
Yeah.
But it's a declare function. It says, we are declaring that there's going to be this function in our code.
Yeah. And fun fact, you can actually have that declare syntax right in your TS, your TypeScript files. If you wanted like declare const hello :string or something like that, you would then be able to refer in TypeScript's perspective to a variable named hello, which is very rarely useful. But sometimes if you're like running in an old browser environment and people did something weird with the global variables or whatnot.
So what declare does is it refers to one specific thing, right? Not a kind of thing.
Yeah, it says TypeScript, I promise you this exists, whether it's a type or a value or something, and just pretend that I declared it with this type shape.
That's super interesting. So in this case, I've declared that hello exists, but it doesn't.
Yeah, but TypeScript thinks it does. So if you start writing like HEL in your code, it'll
oh my gosh,
be like, oh, there's a hello string,
and I can call, won't give you any I can call all these methods on it, but it's wrong. It doesn't exist.
Which brings up a really interesting, fascinating aspect of TypeScript, in that TypeScript is not perfect. Its type system is not sound, meaning it can be wrong. You can do all sorts of wacky things like this that are just blatantly incorrect, and TypeScript will roll with it, which is very different from other languages like Elm or Reason that I personally don't use, but other people are very excited about for being much more correct than TypeScript. It's much more practical than correct, I would say.
Yeah, I've actually never done this before. This is fascinating. Hey, Mark. Good morning. Welcome to the stream. We have a point here about the syntax in the what do you call these files? Declare files? What do you call them?
Declaration files or definition files.
Definition or declaration. See, the D can stand for whatever you want.
What I called it in the book, and I'll just use that.
Declaration
Declaration files.
Sweet. So yeah, this is super. Yeah, I didn't know about the declare thing either. Okay, so when it comes to these files, in this case, we wrote a bunch of like TypeScript code, which was a mix of like JavaScript stuff and TypeScript features, and it spit out this. But the way I understand it, like, is this true? Like, if someone else has a library that's written in plain JavaScript, I can give myself or TypeScript or whatever a declaration file that describes their code without actually editing their code.
Yeah. And in fact, a lot of libraries have this set up by the community, such as Lodash and React, neither of which are written in TypeScript to my knowledge. So if you say import something from Lodash or from React, or is there a React alternative, Dan, that you're a big fan of?
So Solid is written in TypeScript now.
Nice. So although you have that advantage, and I love you for it, that unfortunately means you're not suitable for that as an example on this topic.
Example. I think Vue 2 was actually written using an alternative to TypeScript called Flow. So I wonder if, that's another question. If you use a TypeScript alternative, can you also provide a TypeScript type on top of that? Oh yeah, shout out. Solid isn't a React alternative. Fuzzy says it's a replacement. Whatever you want to call it. Solid, Vue, and React are all examples of things you can import to write an app.
So there's actually a really great website I'd love, if you don't mind, to show, aka.ms/types. I helped write the front end for this, but it was all designed by Order, the mastermind former TypeScript team member who also overhauled the docs. So this is a huge search engine for all the community written type definitions, such as, I promise it's random what shows up on the page. Sorry to keep bringing up React. So there's this huge repository on GitHub called Definitely Typed that has these DTS files for thousands upon thousands of packages. And each of those types are published as an @types/package of npm. So if, say, you need to use React, TypeScript will recognize if there's a DTS file package under node modules /@types/React, or Lodash would be @types/Lodash. So there are a lot of these. I think it's like the most popular active repo on GitHub, or top 5, or some silly thing like this.
So this is so you have to import 2 packages, one for the thing and one for the types. So that's, yeah, it's an example of like you can do these declarative declaration files completely separately from the actual thing. Yeah, I guess I was using Vue as an example of something written in Flow, which is an alternative to TypeScript, but React itself is apparently written in Flow. The DOM expressions repository. This is the rendering system inside of Solid. So this apparently was not written in TypeScript, so it has it separately. People call it a clone. Yeah, I would say Solid is an alternative, but not a clone. So
by the way, I love the Solid idea of like run once rather than repeatedly. It just makes so much sense to me, and I've been wanting to play with it more. I love it.
Maybe if we have a chance, we can do like 5 minutes of Solid plus TypeScript, and then we can accomplish that. I think the types. So there was like a recent overhaul that added some like really nice types to Solid, like parent props, for example, that I'd love to show off. Anyway, back to TypeScript. Declaration files can be separate from the actual code. In this case, it's sort of created by the compiler, right? So the compiler goes behind the scenes and like takes an input and spits out a new file.
Yeah, the compiler does a couple of major things. It type checks your code which I'm going to get real nitpicky here. It's not linting, which a lot of people call it. It type checks for correctness. And then also, if you want, spits out any output files you've asked it for, which can be JavaScript, JavaScript source maps, declaration file source maps. It can be configured to not do file outputs. It can just do type checking, which is actually really common these days because a lot of people will use a faster tool like SWC or ESBuild to transpile from TS to JS. And then TypeScript is just the type checker. But it's sometimes just easier to use TSC, the TypeScript command line, for both of those.
Yeah, so I love our drawing here because it sort of shows that the type checker is something you can just go use if you're interested in making your own compiler, which I am not, but many people are.
Power to people if they want to. There are a couple of efforts to write the TypeScript type checker in Rust, but I'll note that the TypeScript implementation is like tens of thousands of lines of code, and it's always evolving and is very complicated. So good luck to those people. I hope you succeed, but I don't have a lot of faith it'll happen soon.
There's a lot of buzz in the chat, basically trying to validate my current way I spend my time, saying like, oh wait, where is it? Astro.solid is the best stack at the moment, and like between the two of these, this is like my entire day. So thanks so much for validating me. What are source maps? Should we do that now or later?
Ooh, that's a great question. I apologize for bringing it up without explaining. I guess I can give like the one sentence description and we go into it later. It's a tool that lets dev tools map from your compiled outputs back to your beautiful original source to help with debugging when you step through things. But yeah, that's like a whole other deep topic.
Gotcha. They map a compiled output to the thing you wrote. Is that the map idea?
Yeah.
Yeah, maybe the way we should try TypeScript is in an Astro project with Solid.
Let's do it. This will be a learning experience for me.
I mean, I think it's very relevant because you don't just want to like do TypeScript in a playground. You want to actually use it in your app.
Yeah.
So if I go to astro.new, I can go ahead and so jump into an example. So they have templates here for us. I wonder if the component example has a component in it, because that would be useful when you're defining types. So my component has, wow, I see a bunch of TypeScript in here.
Oh boy. I see a bunch of TypeScript in here, and some of it
this is
concerned about.
Very confusing. How about we correct these types if they're not quite there yet? And this example, let's try to actually get it to run first. Otherwise, we'll have to. All right, we might have to choose a different example. Astro team, including myself, take note. We need to fix this example. All right, back to the other examples.
Joy.
Let's do let's hang on. Starter. All right. If this, I usually pick from the top. I wonder if that means I never get to test the ones at the bottom. It's like the TypeScript settings for the playground, which is just a giant list, where the ones at the bottom you never know about. So if we go into our components, here's some simpler TypeScript.
Okay. Nice. All right.
We have a interface, which is exactly what we were doing before. We're calling the interface props. And then we have two things in the interface. We have a string and a href. And href is, ends up being used as the href for the anchor tag. So this is nice, easier TypeScript. So this is an example of like how you can use TypeScript in an actual app, where the idea is whenever we use this author component, so like if I go into a blog post, it imports the author component, and then it goes down and uses the author component. So we're passing name and href to the author, but the language service, like if I pass name as like a number, I should get yelled at by the, I don't get yelled at because we're in Stack Blitz. All right. Well, if we were
Stack
not
Blitz not do the thing.
Stack Blitz does not do the thing because it doesn't have the language service for Astro.
So wait, I haven't used StackBlitz more than Hello World, and I haven't used Astro before. So just so I understand, there's a specific language service for Astro that manages like telling TypeScript and other tools things and then giving back complaints, and StackBlitz isn't running it. Is that how that works?
Yeah, we actually have a team member that I want to recognize here. So this is the language tools repository for Astro, and it's maintained by Erica, who like this is her thing. Like she owns this repository and works on it like every day. It's so much going on to make .astro synchronize with all the other tools. So for those who haven't used Astro before, Astro has its own way of writing components that only run on the server. So in this example, it's kind of like what this component does is on the server, it returns a string that is a div and a paragraph, and then that gets output so that the user can eventually see it. So the syntax looks a lot like just regular HTML, but you can include components. And the way you include components looks very similar to something like Solid or React. So I actually really, really want to show how TypeScript can actually help you in a real Astro project. Maybe I can try StackBlitz. Otherwise, I won't spend too much time. I won't spend too much time fiddling around with this because it's just not super important. Anyway, I'm actually curious about something that I do think I want to bring up, especially if you're sort of newer to TypeScript, is that interface is only one way to describe an object.
This always comes up.
So can you tell us about type?
Sure. I really hate this. I hate that it has been necessary to have two ways to do the same thing in a language because it's at the very least time sink in having to explain it, and at the very worst, and this is also true, very confusing for newcomers.
I want to do a personal disclaimer. I always use type. I almost never use unless I'm in Astro. I just never use interface, and it has never hurt me. Like it never caused any issues. Does that make sense?
That does make sense. I was that way until it caused me pain and issues, and now I'm the interface.
Let's dive in.
So interfaces are great because they let you describe the shape of an object with its methods and properties. There's another way to declare a type shape in TypeScript called type. And type supports a few things that interfaces don't. They actually both have a couple of features the others don't. You can say type ID maybe equals, and then you can have an object shape, or you could just have a primitive like string. Or you could have a union type like string pipe, meaning or undefined.
Okay, so let's just clarify. So interface has to have this shape where it has an object situation, right?
Yeah.
So I can't do like interface options equals yes, no, right? This is a type thing. There's no equivalent way to do this. Like I have to use type for this.
Yes. And that pipe syntax says this object or this type is describing something that can be any of these possible things. It can be the string yes or the string no or the string maybe.
Gotcha. Okay. So can we do an Excel that compares the two?
Yeah.
We have types will be here. We have interfaces will go here. And we can do like a Venn diagram where we will sort of do this if we can, and then bring this down, and then in the middle. Oh no, that didn't work. Okay, And then in the middle, like these things are going to be shared between them.
Sure.
So we just went over one thing that types can do, which is, what would you call that? Like the ability to describe values, maybe?
It can describe oh God, how do you describe that? It can describe primitives. This is the technical term. It can describe like primitives, literals, unions, and intersections.
Okay. Primitives.
That's not what you want to say, though. It can describe things that aren't object shapes. Like non-object shapes.
Non-object shapes. It can also do, I like the idea of like unions.
Yeah.
And
the
intersections.
term there is unfortunate because like in some ways everything is an object. So like I'm not using the technically accurate term, but I think it's.
I just want to address, so first of all, thanks Guerrilla Devs for joining us. This drawing, if I share the link, anyone can edit it, which might be a little chaotic. But as soon as it's done, I'm gonna tweet and like link to the finished thing, so everyone will be able to see the result. But yeah, I will click this button and I have the ability to share it. Oh, here, export as a read-only link. Let's try this. So this I'm gonna post in chat, and y'all can tell me if this is a live updating link or not. I have a feeling it's not. Like I don't think it will update with their new changes. All right, so unions and intersections are their own topic, which we have to address. Can I summarize these as, you might hate me for this. Ors and ands. I guess this is in reverse, right? It would be ands and ors.
It would be ors and ands. Intersection is and.
Okay, cool.
But no, that's how I do it. I had a really interesting discussion with, oh shoot, I'm forgetting who. Maybe it was Andrew Branch. Someone about how when people read code, they tend to use mental terms that are often better and more succinct than the actual names. So like when you look at the union type, you don't think string union number, you think string or number. Like that's how we think of it in our head.
I'm so glad that you said that, because I bet in certain groups, I certain friends of mine would not. They would actually say in their head, union.
Well, your friends need to chill.
Yeah, no. People who basically I'm talking about people with computer science degrees and that really care about all these like mathematical terms. Anyway, so types have non-object shapes. They can do unions and intersections. Both types and interfaces can describe objects, right?
Yeah.
Let's make sure I can actually just like move these further apart as well. Yeah, the link does not update in real time. Someone says in the chat, which I thought was the case. So yeah, like I said, we'll export this as soon as we finish the stream. So yeah, what else can types do that interfaces can't, or vice versa?
I don't know if this is a feature or limitation, but types can't be merged. If you declare a type with the same name twice, TypeScript will yell at you.
Okay, let's actually see what you mean by that. If I declare type options equals, like, let's say we had yes, no here, and then maybe, like these are a conflict. They won't actually come together.
Yeah,
but you're saying,
will tell you angrily about that.
But you're saying that if I define another interface,
yep,
and I add another property here called like age number,
yep,
these come together.
Yep, it's as if you declared a single painting interface with all three fields on it.
All right, yeah. How do I guess I can do painting dot, and we get
which, by the way, I want to call this out. You just did a very good thing. This is how I and a lot of also people figure out what is available. We use the language service where to autocomplete, we do painting dot, and then we see what's available on a type, or on a values type, rather.
I'm curious as to why the compiler doesn't say, oh, look, there's two of these. We can save words if we combine them.
Yes. This is the difference between a compiler and a linter here, where a compiler sees that this is doable, it's allowed, and thus allows it. And there's actually a good reason why this is allowed. You sometimes need to extend interfaces that exist outside of your control, most commonly the global window type or global type. So like if you, let's say, if you're running code in an environment that defines some wacky global variables or some new properties on like the string type or whatever, let's say you have like string has, or array has smoosh, the property function method on it, then you can say like interface array smoosh and so on, and then all arrays will have that. Or like a global variable on window. And TypeScript, there needs to be a way to declare these things because TypeScript doesn't exist in a vacuum. It's used for a lot of JavaScript projects that do funky things like that.
I love it. What we described is kind of like a special JavaScript thing that we do. Things like adding array functions onto onto the array, onto the string, whatever. And so it's like, here's a way that TypeScript can support that. My question was like this output file. Like, why doesn't this output file combine the two interfaces?
Oh yeah, I mean, it could. In fact, you could probably file an issue on TypeScript if you wanted to. My bet is that it's better to not, because it's more indicative of how the code is written. Like, what happens if you have comments there? What if there's a different JS.com?
Oh, will it retain? Will it retain comments? I guess I didn't realize that. Comment?
Yeah, because those are, people use DTS files as the documentation often. Oh no, is it not retaining comments? Try a JS doc like the /star and so on. That should get preserved.
Is it like this?
Oh, thank God. I was doubting myself there.
So this is a really important point. These files are not meant to be for the computer. They're also meant to be like, this is not a compiler output that you're not supposed to read.
Yeah, they're both for the computer and for the human.
Okay, let's make a note here about these declare files. .t.ts human readable output only has the types. Can't be merged. Can be merged. Yeah. Okay. Are these the most important distinctions between the two?
There's one more distinction you're not going to like. Interfaces in difficult edge cases are much more performant for TypeScript to type check than types. They can be cached much more easily, which is why the TypeScript team recommends interfaces. Sorry. They
recommend it because they're more performant?
Yes.
For the compiler.
Yeah, for the compiler. Your output code, it doesn't matter. The types get erased anyway for runtime. But for TypeScript type checking, as if you have weird and wacky cases, like if you're describing the entire set of attributes that can be added to an element in like a design system or the DOM, there are cases where interfaces can be cached much better than types. It's not often, and most of the time it doesn't matter, even if it is faster, but in edge cases, it gets really bad with types.
What do you mean by like cache?
So good question. Good point. TypeScript internally will cache the results of computations in types. Like you can do some really fancy things with types. Like you can say this particular element takes in all the attributes or DOM attributes element properties that a div can, but it can also take in these extra ones. And it also can't take in those ones. Like let's say you have an element that has to take in either children, which is existing, or it takes in like ARIA label or something. Like you can do these really wacky descriptions of the type system and get very precise about what your code needs. So
if that happens once, if TypeScript does that computation, it can then save that so it doesn't have to compute it again later on.
Yes.
So we've known each other for like, maybe an hour, and you already know me enough to say you're not going to like that reason.
Because you said you use types.
No. I'm happy to switch to interfaces. The reason that you should use interfaces because on our side, our tools can't handle the thing we put into the language is not a good reason. Like,
Yes.
just don't allow types to be used for objects then.
It hurts. I agree. You and I feel, are similar on this. It hurts me that this is a user land concern when it's also really more of a compiler concern. But for authors of really fancy types, and by the way, like by fancy, I mean like people are designing systems where you can have generic types where like an element changes which DOM attributes it takes on based off of its tag, like my component as equals div type stuff. Like there's some even fancier things. And sometimes definition authors need to be able to say whether something is the same as another type, whether it get cached, or even whether it gets printed as this like ridiculous huge object type or some like nice name for it. So I agree. This really shouldn't affect users, but sometimes for power users, it actually does leak a little bit.
So given this situation, when, if at any point, should I use types to describe objects?
The rule that we strongly recommend, or generally recommend in TypeScript ESLint, is only use types if you have to. So only for non-object shapes, you can use an intersection.
So you just should not use types to describe objects.
Yeah, okay. You can. I've been in code bases. When we converted Codecademy to TypeScript, we did types by default always, and it was fine. But like just to keep things simple, because interfaces, I guess also sometimes they have better error messages because they're like, technically a type is a cut and paste, whereas an interface is a new object thing. Type is saying, hey, whenever I say this name, what I actually mean is that thing, which is why really complex object types cause really big outputs because you're cut and pasting or copy and pasting. So it doesn't matter, but yeah, I generally recommend interface whenever possible.
Let's see if we can get our linter here. I should probably change the text size. We have blog post. Blog post calls an author. If I screw this up and say like, nah, pass a number instead. Nope. Yes, it yells at us. It yells at us. Yay. So this is the reason why it knows how to yell at us is because of TypeScript. Because type number is not assignable to type string. And it knows that props.name is supposed to be a string. So this is a combination of the TypeScript type checker and the Astro language tools to provide this benefit to us. So shout out to Fred, who's in this example. Yeah, so the author, we can define and we can do like anything we want here. Like, also, is this thing here technically a type? Like, yeah, it's the same. Is this thing the same behind the scenes thing as if I did like type name like that?
Type name equals string. Yeah, you're saying. By the way, we normally do Pascal case, so capital N for types, just to distinguish between variables. Because, fun fact, notice sometimes TypeScript surprisingly lets you do things like name a variable and a type the same. But yeah, when you say type name equals string, you're saying whenever I say uppercase name, what I actually mean is string, and just pretend I put that there.
So I guess a further point is anything I could do here, where I can do like string or number, like, and whatever, like anything I can do here, I could also do here in the actual definition of something inside an interface. So like each thing inside an interface is actually a type. So I want to like point it out here, like contains types. Let me just address the comments. You need to install Astro language support on VS Code for these lints. What about when you run Astro check? I think Astro check uses an ESLint plugin, but you can double check that on the docs for sure. Fuzzy says you use types to define the output of the functions. Oh wait, you dropped down. Your head is below the
standing desk.
Oh, okay. Amazing. Also, I think your mic keeps getting unplugged as you're moving the desk, but it's okay.
I've been turning it off because there's noise that happens when I.
Oh yeah. I appreciate it. Okay, so thoughts about this? Do you use types to define the output of the functions?
I'm not sure what you mean, fuzzy, but I will say you can use types to declare a shape of something that is a function. Like the same way that we were saying, what did we call them? The methods of Painter, whatever we called those before. You could say like type my method equals, and then parentheses arrow to be the output. Like I'll put it in the chat. Like type my method equals painting. Oh boy, the chat converted
Oh,
my arrow.
I love that. I love that. Let me just pull that on the screen. So this is how you can use types to describe functions, and you can't use interfaces to describe functions, right?
You actually can. The syntax is a little weird. It's the same syntax that we see on, say, line 16, just without the name. You're saying it's not a method or property that has the ability to be called. It's the thing itself.
Interface, my function. I can say like number goes to. I'm so curious. What if I did this?
You're saying this always returns exactly the value 6, which is actually a topic I normally bring up pretty early on for people, that there is a difference between a literal and a primitive. A primitive is like number, any number in the universe, whereas the literal is specifically this instance. It's specifically 6 or yes or no or something like that.
So by the way, this is just kind of funny to think about. Like this function always returns 6. So, but aside from the memes, like, if I need to declare the type of a function, I can now think of 3 ways to do it. I can use the syntax in your comment that I put on the screen. I can use an interface, or I can just in my function type everything I do. Right? Like in this example, we didn't use either of those 2 options. We just typed the arguments and typed, well, here we didn't even type the return value. I guess we didn't have to because it knows. That's kind of interesting. So since we have 3 ways to type a function, how do I choose which one?
Oh boy, this again brings up the difference between a compiler, which is the tool that type checks for correctness, and a linter, which gives you general recommendations on how to structure your code. Most of the time, we recommend that you use the type strategy if it's its own standalone thing. Like if you have a variable or function parameter that is a function, use the type thing to give it a nice name. It's confusing what we have on lines 23 through 25 for a lot of people, that it's an interface that, I'm sorry, not 23, lines 19 through 21, my function. That's like confusing for some people.
All right. So
to type out.
So it's like recommended, use this when it doesn't have to be like a separate thing, a separate reusable thing. And then use a type when you want a reusable type for the function.
Like cool. I personally, so right now the painting function takes in 2 values that are object types. If one of those parameters were a function type, I would use like a named type, whatever the name is, equals.
Oh, because
that's how I would personally recommend.
It would just get confusing. Like if I did like callback, and it was like, I have to put on another line already. Like this, like painter, exactly. Boolean or something. So like, I did this wrong.
You have to use the arrows when it's an inline type. Fun fact.
That's actually
this is getting unreadable. Like this is
so instead of doing this, I can grab this and say type callback equals all that, right?
Yep, exactly.
And now I can do callback. So this is like a way we can make our code a lot easier to read. And also now we can reuse this. So if somewhere else we use the same kind of callback, we can reuse this type. So sweet. Wow, I feel like we've already covered like enough that you can like use TypeScript to write your app or improve your app. People are talking about the Astro check linter, which we really need to dive into. But wow, yeah, I'm already like feeling pretty great about types, interfaces, what the heck this declare thing is. There are. Oh wait, you disconnected the mic.
Sorry. Could I interject with one last topic that I think is really cool and important and fun? Is that okay?
Yeah,
Do we have time?
No, we have. I mean, I have as much time as you have. Usually these streams go for 2 hours, so we can dive into like really cool concepts.
Yeah, I have like several hours. This is awesome. So
Sweet.
we talked about the difference between primitives and literals a little bit. TypeScript also has this concept that we've somewhat covered of unions, where something can be either or. Like on line 12, you declare that something that is type options can be either the string yes or the string no. TypeScript, by the way, this is something a lot of programming languages like whatever, C#, Java don't have. TypeScript also comes with the concept of narrowing, which I personally find hard to say as a word. But it's the idea that you might in your code have areas where a value is a more specific type than it's declared. Like, let's say that you have
actually let me
a
just
function.
Let me just add one more so that we can. But like, I'll do a function. You want like a function that takes in this type, right?
Yeah.
Function like evaluate options. Sorry, this shouldn't be options. This should be uppercase. I need to use TSLint or whatever because in my own code base I often use lowercase. I actually always use I use lowercase for types and uppercase for interfaces, which I'm sure is not recommended.
Oh yeah, you just hurt me a little bit deep in my soul, but that's okay.
By the way, one thing I should throw out there: the most fascinating, useless developer debate I've seen is on this thread on GitHub where they argue about whether you should preface your interfaces with the letter I.
Oh my god! Oh.
What a
time waste.
It's an endless debate because people who come from C# do that. Anyway, back to this. So if I say, let's say I'm like, okay, yes and no are special, but like if someone gives me maybe, I want to like return early or something, or like ask them again. So I can do if options equals maybe. And then what you say about narrowing, does that mean that inside here, options is effectively just maybe?
Yes. You already have done this before, I infer.
Yeah, sorry.
No, this is great.
I'd rather get you to explain it.
No. I like this. This is actually a really good explanation that I'm going to steal from, and this makes me happy. But yeah, exactly. Within this if statement, options is we know it's maybe. The only way this code could be reached is if it's maybe. Beautiful.
So this is called narrowing. I'm going to put a comment here. Narrowing. This is a feature that deserves its own bubble. So we have up here some stuff. We have unions and intersections, which we've sort of described as, as ors and ands. We also have type narrowing, which it works with unions. Sorry, it works with intersections in this example, right? This is an intersection of a bunch of types. No, union. What is this?
Union.
This is confusing. All right, we're gonna go back to ors and ands. This is a giant or. It's yes or no or maybe. But from my previous understanding, which I should declare up front, we can also use narrowing with objects if we're not sure what kind of. Actually, is that true? Could you use narrowing to like narrow down object properties? How would that work?
Yeah. If the object property is optional, like if it's name, string, or undefined, and you check if thing.name, then inside that if statement, thing.name will be string because it's truth and therefore must be a string.
Let's bring up this feature, optional. So let's say I want the age of the painting to be optional. I can go into it and add a question mark, right?
Yeah.
So now, if I roll over, I can't just roll over the type. Apparently, I have to roll over like the specific thing to get all the like painting dot. I guess I have to do it. Yeah. So now it still has age in here, but it says number or undefined.
Yeah. So when you have a painting, because you declared it with a question mark, you're saying this property may or may not exist. So any object. By the way, we haven't even talked about structural typing. That's a whole thing. Excuse me. A painting object does not need to have an age property. If it does have the age property, then it must be number
or undefined. Well,
depending on your TypeScript compiler options, they actually added an option that made it so that there's a difference between a property existing and being undefined versus not existing and being undefined.
Yeah, I guess it's super interesting that I'm allowed to like call painting.age, but I imagine if I did like painting.age +4, it would freak out.
Yeah, because when you just ask for painting.age, you're getting back number or undefined. And TypeScript knows that, hey, undefined +4 is a weird operation. I'm not going to allow you to do that.
Right. So we can use our type narrowing. So like let's do something actually useful, like console.log 2022 minus painting.age. So this will tell us the year that the painting came out. So let's say I want to do this, but I don't want TypeScript to yell at me, so I want to do it only when I actually have an age on the painting. How would I narrow?
Great question. You would, if painting.age is one way of doing it. Although actually that brings up an interesting point of what if the age is 0? So we should probably do like if paint.age not equal to undefined, which is something a linter would check for. Strict Boolean expressions. Oh boy, the internet's going down.
Oh, are we still connected? Chat, let me know if you still hear me.
Hi. It's rough, but I think it just went back up.
Oh, it's on your side?
I don't know.
Okay. Well, we'll hope that we're good, and chat can tell me if you know where sort of the issue is. But what if I did this? Is that
you
not
could
a thing?
Do that. Yeah, if type of painting age is number or is not undefined, yeah.
I'm always curious about the type of operator, and if it's really like you should avoid using the type of operator as much as you can.
That's a good question, actually. I don't personally have a preference. I'm sure there's some like deep language concerned about the difference between instance of and type of or whatever.
Can I say why I like to avoid it? Because what if you do this? What if you add like a letter? Yeah, like what if you screw up the string?
TypeScript will yell at you.
TypeScript will, right? That's true. Thanks, TypeScript. It's so funny. Look at this. This condition will always return true since the type string, number, big int, bullet. Like this tells you all the things you can use with type up. So TypeScript not only helps you write your code, it helps you use JavaScript's confusing things.
Yeah. That's so smart, actually. That's a good way to figure out. You were asking earlier, like, what is the list of all the things?
Yeah, this is all right. Well, so we use type narrowing to basically say within here, painting.age is a number. It's not number or undefined. Like it is for sure a number because we already said it wasn't undefined. So my question is, how the heck does TypeScript do that? Do they like run this code behind the scenes?
They don't. They convert the code to what's called an AST or abstract syntax tree, which is a way of describing the full shape structure of your code. let's say you have a function that has an array of parameters in a body, and that body has an array of statements, and so on and so forth. And then once they have that AST, this way that they can look at your code and understand it, they then check. They check for a whole bunch of known issues, like declaring a variable with a type annotation and a value that doesn't match, or providing something that's of one type to a function as an argument where the type is supposed to be something else. And one of the things they check for is the two sides of a equals or not equals. Are they definitely going to never be false or true? Like, is it always going to be the case that, like, if you check if 1 triple equals 2, we know that the types have no intersection. There's no overlap between those types. So it'll give us a complaint.
I actually love that. It prevents you from doing stupid things. Like if 1 equals 2, I guess, yeah, it just tells us the condition will always return false. So it yells at us. You know, I wonder if it will yell at me if I say if false. No. It doesn't see that. It doesn't see that as a problem.
It could, but I think enough people use this as like a debugging tool that they got yelled at and either took it out or never had it in the first place.
That's so funny. Like if you have a complicated expression and you're like, no, just to debug it, make it false. I love that's so funny. Okay. TypeScript lets you do that. Cool. Wow. So, all right. So that gives us a really good look at as to like the TypeScript behind the scenes. It understands how your code works. It's a little bit more than documentation at this stage, right? We said, we earlier said that there were like 2 main things that TypeScript can do for you: documentation and catching issues. Sometimes these things overlap. If you have better code documentation that describes the shapes of your objects, you'll catch issues, but sometimes they don't. Like in this case, this is just TypeScript like catching issues. This isn't us documenting anything. This is TypeScript saying like, you probably don't want this in your code.
Yeah. The type checker can get surprisingly advanced sometimes. Like if you have asynchronous code and let's say you have an if statement that takes in some value and the value is a promise instead of awaiting the promise, TypeScript will tell you, hey, you said if promise instead of if await promise. Did you mean to await that promise?
I love that also because actually, can we just demonstrate if I declare an async function and I don't type it? I want to see what happens. Fetch Josh book.
Hey, thank you.
All right. If I don't type it, does it know that it has to be a promise? Yes. Look.
It does.
Promise void. So this is actually amazing because if you're learning the language and you don't know what this async function is, like it will now like help you out. So if I misunderstand what the idea of async is and I'm just like, okay, like return learning TypeScript, I expect to see an issue here, but I don't see one. Oh,
it infers.
Right. Okay, so it just automatically made it right because that's what the async functions do behind the scenes. They turn whatever you return into a promise. So in terms of the type, it now knows that it has to be a promise. So on the flip side, if I call this, if I go like, I don't use await, so I just say fetch Josh book and I do dot, I should get catch and then, which are not things on the string, they're things on the promise. So it helps us out and makes sure that the type is a promise for you. And if I do await, so like const book name equals await, this would have to be an async function to do that. Then TypeScript tells us it's a string. So it sort of unwraps that for us. Now, there's something we encountered along the way that we have not brought up yet, which is these angle brackets.
Oh, God. Took me a moment. Yeah, generics. The single best and worst language feature for everyone. Everyone hates them. Everyone.
What the heck is a generic?
It is the concept of part of a thing being different in every instance of the thing, potentially different in every instance of the thing. There is an idea of a promise, and every promise has some things that are the same, like it has a .that, it has a .catch, but different promises have different data associated with them. So we declare that the promise class or type is generic in that the data type is, in this case, let's say string.
What would you say is like the simplest example of making a like using generics on the creation side, like making a type that takes a generic or something?
The example I normally start with is the identity function, which takes in a thing and just returns the thing directly. No funny stuff.
Function return self.
Sure, yeah. Like let's say that all this does is return the one parameter, like takes in a self and returns self. Like what type is self? Is it any? Is it string? Like in this case, you would say that this function should be generic because if it takes in a string, you should know that it returns string. If it takes in a number, it returns number, and so on.
I'm gonna move this over. So in other words, if I said, like, if I want it to work for any object, there is an option where I could do this and it would work. Why is this a bad idea?
It is, because I feel like we're playing volleyball, like set spike. It is a bad idea because any loses type safety. Any says this can be whatever I want it to be. Don't use type checking or most type checking. Just let me do whatever I want, YOLO. So when you call return self with self-defined as any, the return value is type any, which allows you to mess up. You could say return self 5.2 uppercase, which we as humans can read as wrong, obviously. But TypeScript says, hey, you told me any. Knock yourself out, buddy.
All right. So basically what I'm understanding is that anytime we use any opts out of TypeScript's helper stuff. So as soon as we said it was any, it's like, all right, I don't care anymore. I'm walking away. Like you can do whatever you want. So in order to fix this, how can I use generics?
For a function, you can say that there is a type parameter, meaning a type that can be different each time the function is called, with less than sign, whatever you want to call it, typically T if you don't have a better name, and then right. Yep. And then no colon, just T. And then you can say self is type T instead of any.
Oh man,
we're saying
it instantly showed up now.
I see what you're doing. Yeah, you're saying whenever I call this function, T is whatever I've provided as self. So in this case, return self 5 means T is number, or 5, the literal. And yep, type 5 does not have 2 uppercase.
Okay. So in this case, generics are kind of like this behind the scenes tool. Like on the calling side, we didn't even know. I guess if I roll over it, it fills in the gaps for us. When we because we passed 5, it just goes in and it's like 5 self 5 returns 5. If I passed hello instead, it's return self puts string everywhere because the type of hello is string. And it just, I love it. It like copy paste all over the place. Actually, if I wanted to do this the explicit way, I could do that, right?
Yeah. TypeScript will infer the return type of a function based off of what the function practically returns, but you can be explicit here instead if you want.
Can I do a check inside here for like, if it's a number, do something special?
Oh boy, I guess you could. What would you want to do?
I don't know. Log to the number logging side effect that shouldn't be in the code.
Sure, yeah. And inside, and then you could use narrowing there, where right now T starts off as unknown. We don't know what it is. And if you say if type of self is number or some similar thing, then yeah, inside the if statement, self would be number.
Number.
Oh, look at that auto completion. Love it.
Run evil side effect self. Cool. And this would have to
Actually, wait, can you do the quick fix for run evil side effect? Oh, lag.
quick fix. Add missing function.
Yeah.
Where did it go? Where did it go? Here. Oh wow.
Whoa, that's a bug.
T and number. Ah, we found a bug. Let's report it.
Yeah. But that's correct. In TypeScript, I mean, other than the fact that this function doesn't know what T is, like inside that if statement, we knew that self was not just T, whatever the generic is, but also it's a number.
Yeah, so we actually, this is the correct version of it, like no T mentioned at all.
Yeah.
So this was writing your code backwards. This was like, we said, like, we're going to call an evil side effect that takes a number. And because of TypeScript, our IDE was able to tell us, hey, you should probably write a function that takes a number.
Yeah. Very,
very cool. All right. That was a sweet demo. Okay, so we've covered, I think here's an interesting thing. So this is, again, me injecting my prior knowledge. If I want, let's say the painter, where's painter? Yeah, this is like everything is super messy and all over the place because we've been adding things anywhere. Let's say the painter has an array of paintings, like past work. So I can do this two ways. I can say painting like that, or I could say array and then use those generics. Painting. Is there like a difference?
No, they're basically identical. In general, we in the like linter side recommend you use the simpler one with the array brackets because it's just easier to type. But yeah, and under the hood, arrays are generic, and they're actually a really, really good example of a generic. I'm glad you brought it up. And this is what an interesting order to teach things. I actually really like this because the array class is a generic class. It stores some data, which is some type T.
So if I wanna let's go to a spot. First of all, let's just like move the painter down to, or move this up. Our painting. I'm gonna remove this. That was a cool demo. And now that I'm up here, I'm gonna be like, okay. So if I say painter.pastWork, equals like the wrong kind of thing. So here I'm saying, look, I'm giving you an array. Why aren't you happy? And TypeScript is saying back, well, you gave me an array, but you didn't give me a painting. You gave me a bunch of numbers. And so that's why we get type numbers not assignable to type painting. And so this is kind of like granular, like it goes down a level. So like if I can correct one of these and see what happens. So I'll pass painting. And now I won't even get an error on like the entire line. I'll just get an error on the ones that are wrong.
Yeah.
And that seems to be like a power of generics, which is like we can like step into, I don't know how to say this. Like it's no longer just about being an array. It's about being an array that has the correct value inside of it.
Yeah. TypeScript looks nested levels. It'll keep going down to make sure the entire thing is the right thing, not just, it's any array. Yeah.
And what if I just did this? Oh, it yells at me. It yells at me.
You could do array any, but at that point you're again erasing TypeScript type safety. You're saying, whatever. Let me do whatever I want.
So this is an interface that takes a type function. Sorry, what's it called? Type parameter?
Type parameter. It matches function parameters are what you declare, arguments are what you provide to it, which is a nomenclature difference I did not know for most of my career.
Yeah, that my eyes glossed over when you're like,
yeah,
like but let's go talk about generics here. So, Well, first of all, we did talk about any. What did we say about any? We basically said kind of no. Like don't do that because you don't get you lose benefits. So I'm gonna say opts out of TypeScript helping you. We didn't talk about never.
Or unknown, yeah. I'll say there are some cases where it's reasonable to use any, and you should not feel too bad about yourself. Don't be sad about using any. Sometimes TypeScript's like the type system is too opinionated, or your code you just need to get the dang thing to work. Like it's okay to use any, but most of the time there is generally a better way of doing things.
All right, I put that into the description.
It's a good escape hatch.
Escape hatch. Let's call it that. Escape hatch. Then we're gonna talk about generics. So generics, and I guess I'll bring that up here. Generics are similar in some ways to the idea of an intersection, because it's kind of like saying this type can be an array of strings or an array of numbers. So we're going to say generics, they take a type parameter. Like, well, that's what generics are. It's like a type parameter is kind of like, I guess, the definition of it. I guess you could define it either as the type parameter itself or the thing that has a type parameter, but I don't really know.
Yeah, it's a loose term. But I think I haven't thought about this fully, but there's kind of a maybe intentional naming overlap that functions take in parameters and generic things take in a type parameter.
Mm-hmm.
Like you're taking the thing and a type and getting some output type or function or whatever. There's something interesting there.
What I can say about that is like functions of a type parameter. Like they're not a literal function, but in that sort of mathematical sense or in metaphorical sense, it's like they take in a type and they output a type, right? Like they take in a small type and they're like, I will use this small type to make a big type.
Yes, I like that.
People are talking. Oh, you put the repro for that bug, so thanks for that.
If we have time at the end, I'll try to peer pressure you into filing it on TypeScript.
Actually, let's do it now. I think I really want to learn how TypeScript as a project works.
Yeah, their issue tracker brings me so much joy. They have all the different label colors and everything.
So let me first open. Oh, I didn't want to put that on screen. It won't. StreamYard won't let me copy the link, so I have to like go onto Twitch itself. Very annoying. But all right, can you post it in the private chat we have? Because I can't copy and paste it.
I'll also note that we have a special guest appearance. Sorry for calling you out, Nathan, but a member of the TypeScript team just pointed out that the bug can actually be simplified. It doesn't have to be narrowed.
Nathan, thanks so much. Thanks so much for joining us. I am going to call you out. Thank you.
Nice. Even better.
All right. So I'm going to go ahead and pull this. So can I use this as in my issue?
Yeah. Normally at the beginning of filing an issue, you'd want to search for existing ones. I did a brief one, but I was paying much more attention to you, the issue tracker. Curious, Nathan, who's now in the Twitch chat, has.
How do I find where to
this?
Do I just go into this?
Yep. It's one repo.
There are only 5,000 issues. I'm sure Nathan has plenty of time to go through them all.
Only 5,000. Yeah. It actually used to be way higher than that. Cool. So let's just assume it doesn't exist already because Nathan said so. Cool.
This is going to be a bug, right?
Mm-hmm. I love this. I love this issue flow that we're getting to GitHub. having the like specific bug report template. I remember when we didn't have that. It was such a pain.
So in terms of the example, Nathan said we should, we don't really have to use number. We can just say run evil side effect. And if we quick fix, it will do something nonsensical.
Nice.
Okay, so I can share. Actually, that's what, comment this one out, and then how do I export or share? Oh, URL copy to clipboard. I guess is there a slot?
Say the TypeScript team hasn't yet moved to GitHub issue forms, which would be great. And yeah, there's a space.
Playground link with relevant code. Do you want me to put the code sample here as well?
Yeah. That way it's a little easier just to look through the issue. I love this. This is awesome.
Cool. So in terms of actual behavior, TypeScript generated this function, which is an invalid function declaration, because it wants us to explain why it's wrong. So I'm saying it's wrong because it's not a valid function declaration.
Yeah, I think it should be generic. That's my hunch for what should be done. That if self is T, then anything that uses self, like any other function, should also be generic with that T type. That's my guess.
So in terms of expected behavior, we want it to look like this. Actually, I could just do it here. So same idea, but we would rather it actually add a type argument to the function. So it would be T.
Yeah.
Wait,
that makes sense to me. What do you think? What's your feel?
Wait, I need to get the highlighting to work. TS, TS. Yeah, it's it doesn't make sense for when we use the type narrowing. This what I'm saying is there might be a separate issue, whereas like this makes perfect sense in this example. You want to bring everything over, but like the T and number thing should not. It should just be number because we actually narrowed down the type. So that might be a separate issue.
It might be, but I actually think it's not. What if the T is 0 or 1 or the string LOL?
Okay, and then we narrowed it. We said it was a number, but if I see, I understand. Yep, we need that union so that it won't just be any number. It'll be 0 or 1. Wow, cool. Okay, yeah. So I hopefully we might have to like explain that real quick. So basically,
yeah.
if I edit this, it's not a live URL or anything, right? Like it'll change the URL every time. Like I can
the URL is just the code encoded.
So like if we go in here and we say, if type of self is a number, call this. And we called identity saying, I guess we would have to. I guess
you can manually specify the generic if you want.
But I could also just do this. Type special number equals 0 or 1. And I can say const my number is a special number 0.
Yeah. Well, actually, fun fact, what's really common for people reporting issues in TypeScript or TypeScript ESLint is to use declare const. So you don't have to provide an initial value. So you don't get into weird cases where like TypeScript has inferred it to be 0, even though you said it's the more general special number. So declare a const number colon special number. So you'll have to give it, I think you probably want a different name for the variable just to be not the same. Yeah.
Now I can call identity my number. And basically what we're saying is once we're in here, we can't go and create a function that accepts any number, because in this case, with what we pass, we can only assure that it's 0 or 1. So that's why we want this to actually be t and number. And is not actually, I guess it is and here. It's like it's both a number and also within t. And that would be correct here. So the correct response would be like this.
Yep. And if you had like special number 0 or 1 or undefined or something, now we're saying it's no longer undefined. It's whatever t is, and it also has to be a number.
Right. So this is basically what we're saying is we're learning from both sides of this.
We're learning.
We're learning, and TypeScript is learning from us. Let's okay.
By the way, Nathan mentions in the chat, the t and number 2. It could be another wrinkle. And yeah, I feel like the other function, like, does it actually need to have t and number? Like, I don't know. I don't see a need for it.
I'm gonna mention
in this function the t is different.
I'm gonna mention it, but I'm not going to write it up fully. So this will be a separate link that I'm going to link to. So I'm going to say share. I can say see also unexpected behavior when type narrowing in this example. Whatever. Okay, so bug report. How should I actually describe the bug report? Should I say the quick fix feature generates, allows us to generate a missing function when a missing function, but doesn't correctly declare that function when it must accept a generic. When its parameters include a type parameter. Should I say a type parameter or a generic?
Yeah, type parameter I think is good. I'm like going through it in my head.
Okay. Search terms. What search terms did we use to look this up?
I personally used whatever the name of the quick fix is, add missing function declaration, and then also a generic type parameter. I say generic type parameter because some people call it generic, some call it type parameter.
I don't really know what to do for version.
So on the playground in the top left of the screen, or the playground where it says v4, yeah, you can switch that to the top one, which is beta, just to make sure it still happens in 4.8. If this is already fixed in 4.8, that would make me very happy, but also sad for spending your time. Nope.
Do you want me to go all the way back and see if it was always there?
Yeah.
Oh no, it just that's too early. It won't give me any suggestion there. What about this one? Quick fix.
It's cool how like the output is different in each of these.
Yeah, it's always been there. I think I can conclude. I am unable to find a version of TypeScript where this was not a problem. Okay, can I go ahead and submit the issue?
It looks good to me. Oh, title.
Quick add missing function declaration does not correctly correctly declare generic function. Is that a good title, or it's very wordy?
You know, a lot of these end up being really wordy, especially when you have like generic and type arguments and parameter and stuff in there. But this looks great to me.
Okay, I'm gonna go ahead and submit it.
Woo!
This feels
Worst
amazing.
case scenario is the team hates you, and just kidding. Yeah, it's a good feeling, right?
I love this. I love this. Yeah. So, huge props for this wonderful template. I love how everything has emojis. And huge kudos to this team. Is the team all like employees at Microsoft, or is it a broader sort of team for TypeScript?
I'll let Nathan correct me if I'm wrong here, but yeah, it's employees of Microsoft. I think Orda also does random work for fun, just because Orda is this person who enjoys that. And then there are also like some community members who pop in and out. There's one person, Alexander Tartsiuk, who just sends a bajillion pull requests, and then like random other people, like, oh, the first PR there was from Andrew, someone who's really active with X States. So like it's a community involved project, but Microsoft team run and led.
Is TS server the language server?
Yes.
So in here we have, can we find our four things? We have TS server, which is language server, TSC, which is the compiler. Our other two things were the type checker itself, which might be all of this.
Yeah, TSC and compiler.
Well, compiler is TSC, right? It's the CLI at least.
Yeah, the TSC CLI calls the compiler functions, the APIs. But yeah, if you search for checker.ts, like the GitHub T search, checkered TS, I think is somewhere in here.
Wait, how do I search in here?
That's the giant file that is the type checker.
Oh, what do you say? Check.
You're gonna love this. Press T on your keyboard.
Oh no, I'm using a Vim extension. I'm using a Vim extension. It won't.
I love that you use Sourcegraph.
Yeah, so the reason why I can't use normal shortcuts is because my browser overrides it so that T opens a new tab. So
that's so funny.
Where is it?
I was all excited about using T. Is there a way to get just search for file without the shortcut? Surely there's a link somewhere.
I mean, I don't know. We might have a latency problem. Internet. Yeah, I think we have an internet problem right now where it's kind of behind. But anyway.
Oh, it's a go to file. Oh, that internet, that lag. Oof.
It's a 2.69 megabyte file. This is huge. This is very big.
Yeah.
I can scroll for hours and hours and hours. Holy crap. Hey, Ben. Thanks for joining. We are just about wrapping up, actually. We ended up submitting an issue to the TypeScript project itself. So I feel like we did the ultimate, getting started with TypeScript stream, where we not only explain what TypeScript is and some of its features, but how to help improve TypeScript and how it's a project that sort of goes beyond just something you have in your IDE. Meanwhile, I submitted a PR as well. Thanks for submitting a PR to the Astrodocs. I'll make sure to check that out and merge that. Sweet. Josh,
Nice.
are we still having connection issues?
We were, but I think they just resolved themselves. Good timing.
Awesome. Yeah, so I guess it's sort of time to wrap up the stream. One of the things I want to make sure people know is your book. So if we go, the best way to find Josh's book, if you forget the name, is to look him up, and he links to the book as like the first thing on Twitter. So everyone go follow Josh on Twitter as well. And check out Learning TypeScript. Learning TypeScript has a Twitter account that tweets. It's a sentient book. So definitely go and try that out. Anything else you want to plug?
Well, first off, thank you for having me on. This was a ton of fun. I really appreciate a lot of the ways you explain things, most notably with this like Scala draw system. I really like that. That was fun. But yeah, thanks for plugging my book. Buy the book, give me 5 stars. Y'all can also sponsor me on GitHub. I'm on the TS ESLint or TypeScript ESLint project. We provide a whole bunch of tools that help you sanitize and check your TypeScript code, TypeScript-ESLint.io. So
I want to pull that
always
up.
welcome to contribute.
Let's see, TypeScript.ESLint.
TypeScript-ESLint.io. We should get that to be a redirect, actually. We're the tool that lets you run ESLint on TypeScript. So we are neither of those two things in our title. We're a separate entity.
If you're someone like me,
actively working on this.
If you're someone like me who doesn't have ESLint set up in your side projects, this is a good opportunity to set up ESLint and make sure this is like built into ESLint, right?
Oh.
Are you back? Are you there?
Oh yeah. Brief moment.
Is TypeScript ESLint built into ESLint?
It is not. It is. So actually, I'm a relatively new maintainer. The previous folks worked with the ESLint core team to add like a bunch of APIs and structural improvements to ESLint to support this. But it's like tooling that uses ESLint APIs and TypeScript APIs to merge the two together. And yeah, the site was mostly accessible. And thanks to Ben, whose audit had some issues that I still haven't finished reporting on GitHub. I will get to it soon, I promise. The site's super accessible.
Ben is the accessibility fairy. He comes around to all the projects and just like, does an audit, fixes issues, and make sure that our sites are accessible. So huge thanks to Ben. With that, everyone, thank you for joining. Josh, thanks for coming on. Thanks, Nathan, as well. Special shout out to a TypeScript team member for helping us out. And yeah, you can find us both on the internet, and I hope you do. I hope you reach out. So everyone, have a great day. Have a great week. It's Monday morning. I did a stream in the morning. What? So
Yep.
Thanks so much, everyone.